Hello, welcome to Node Spaghetti. My name is Joseph, and today I've got a brand new Riggy Bits video for you. Hey, wait, what's this? That isn't Blender. Where's Linux? No, I haven't betrayed all of you. In fact, I've actually just made something really cool in Maya, and I wanted to show it off. I'm going to port this over to Blender anyways, so don't worry about it. I don't plan on making Maya videos very often, however, so if you want me to make more Maya videos, maybe consider sending a $2,000 donation my way? A quick note before we begin. If you see a comment that says, "Wanna be friends," do not click, do not respond, don't check it out. A bot wrote that comment, and he's trying to use it to steal your channel. This problem doesn't seem to have been noticed by YouTube yet, but hopefully it won't happen on my video, and if it does happen, I'll delete it right away. Also, if your comment looks like it was written by a bot, you might find that you're not able to write comments on my videos anymore, so be careful. And honestly, this bot is part of the reason why I haven't uploaded in a while. If you want to be my friend, then just send me an email. And yes, I know it's been a few months since I've uploaded anything. I haven't disappeared. There's just some things going on in my life that are forcing me to prioritize my time a little differently. So please forgive me for taking breaks. I haven't gone anywhere, and I have great ambitions for this channel. This model here is from my university short film, Stick to Manual. Please take the time to watch it. I've left the link in the description. Now this is a pretty complex rig, and it was actually the first in-depth exploration I've ever done of Maya's rigging toolkit, or for that matter, Maya's Python API. So let's select the parent control of the rig, which you can use to translate and rotate and scale the entire rig, and it even works with nonlinear scale, which is something I hadn't planned for, because honestly you should never do that, but it still works, so hey, that's good. Anyways, let's turn on the visibility of the individual pages. And you can see that there are several pages. There's actually 9 of them, including the covers. The covers are included because they work using exactly the same method as all of the other pages. And you can bend each one individually, and it's very easy to use, and it's a lot of fun to use. And each individual page has got its own set of controls, which gives you a lot more options for intuitively and easily posing the book. And I've actually set up a scene that shows all of the complex and flexible and fun motions these pages can do. Let's switch over to that now. And you can see what this rig can do. Only the controls that are being used are shown in this animation. So all of this animation is done with just the bend controller. Couldn't be easier for an animator. And there are individual tweak controls, and there are bending tweak controls. And of course, the parent control can move and rotate and scale the entire thing. Let's have a look at each one individually. This is the bend control. It's a lot of fun to play around with, and it can stretch the page too. And if you don't want it to change the scale when you stretch, you can turn that off. But I like it, so I leave it on. And you can bend the page, and obviously when you're animating a page turning in a book, the direction of the bend has got to change at some point, so there's a control for that too. So now it bends the other way. The bend control is an IK control, and I set it up so that it mostly does what the animator wants it to without the animator having to do any kind of work. And it only gets kind of wonky in the more extreme poses. For the most part, it just works. So, it can move along all 3 axes, and that won't cause any kind of problem. Although it's primarily meant to only move along its local x-axis. And I think you'll get the best animation curves and performance if you use the parent control to turn it and the bend control just to bend it. I think it'll make the graph editor a lot easier to manage if you do that. The bend controller has one more parameter, and that is a feature for fixing the pinch that happens because I'm using a lattice deformer. And you can set the effect however you want, and you can even animate it if you want to, although I don't really think that's necessary. And there are more controls visible in this rig.
Well, they're not visible right now. There are more controls that are not visible. Yes, make them visible for you.
These right here are tweak controllers for the bend. They operate on top of the bend controller's animation. So you can use them to adjust the bending of the page. And these are a lot of fun to use, and they operate in all 3 axes too, just like the bend controller does. And the reason I did that, in case you're wondering, is because each of the books in the film had an automatic opening and closing animation, and I wanted to make the pages turn and flop believably. So I made these controls so I could override them using a parent with a driven key. It's a lot harder to do that sort of thing when you control something with the property of an object, because you can't override that and then animate over it, and you end up having to use a bunch of math nodes to make that work. This solution to the problem works just fine, and it gave the animators another set of controls for tweaking their animation. Win-win. Next up, let's look at the tweak controls. And as you can see, the tweak controllers will follow the bend of the page no matter what, even if you go too far with it. Now, the bend control itself won't allow flipping, but the tweak controls will. And you can see that each of the tweak controllers follows the bend of the page no matter what, and it's automatically positioned in the right place depending on how much the page is bent. And you can move each one individually to get these really fluid and unique and specific deformations, whatever fits your character or your action. And you can twist it around a little bit and rotate them, and you can actually automatically twist the whole page by twisting the bend control. And it looks just fine. I'm actually surprised by how well this works. It'll even work when you've got the page stretched out all the way too. And of course, these all work on top of the bend control twist. Now there's another layer of tweak controllers that allows you to edit individual points on the page. And this allows for really flexible motion, and perhaps it's overkill, but you know what? I got this action for free because of the way I put the rig together, so why not add it? Maybe the animators will need it, right? And posing this is just like adjusting the points on a NURB surface. And the reason for that is because of the way the rig works. That is, with a complex network of spline IK chains. Let's take a look at those. There are actually 30 spline IK chains in all. And the skin joints here, they copy between all the different spline IK chains. And you see how it's halfway between them? That sets the position of that section of the lattice, which then in turn deforms the page. And the tweak control moves the control points on the NURBS curve, which of course moves the spline IK chain. And at this point, a bunch of stuff gets reset because I've got keys set on them. There's a bunch of animation in this file. I just moved the timeline to a part where you don't see the animation. The next main feature of this rig is actually a simple IK chain, or rather 2 of them. Here, and here. It is these 2 IK chains that sets the overall bending of the page. And you can see there's a chain of joints in between them that copies its rotation between the 2. Now at first I had tried to make a single IK chain flip back and forth, but copying between 2 of them ended up being a lot easier to do, and it ended up being better for the animators because now I could do this. See how it smoothly interpolates between the 2 chains? If this was pure IK and it was controlled by a pull vector, then you'd have to stretch the page out and then change the location of the pull vector in order to avoid like a weird popping animation that occurs when you change the direction too quickly. Let me show you that. Imagine what that would look like in animation. That would be ugly. So smoothly blending between them, it looks a lot nicer. It's a lot easier to do. And it just works. It was easier for me to rig too. Now I'd like to show you the process of rigging the page with this script. It's actually very simple. Select the object, run the script. It's that easy. It selects all the skin joints, so now all you have to do is bind the skin. Come on, Windows, why are you doing this to me? So let's go ahead and do it. Select the object, bind the skin. well, that's not actually what we want. So ugly. Obviously, if you're going to use a set of skin joints to deform the page, then you've got to spend some time painting the skin weights, and painting skin weights is such a pain in Maya. Now, while I was developing the rig, we were planning on having 3 variants of each book. We were planning on having 5 or 10 books, and the first variant had 1 page, the second had 2 or 3, and the third had 5 or 6. So I'm thinking, I might have to rig 30 assets, I might have to rig more than 100 pages. I am not painting skin weights for each one. Not gonna happen. So instead, I found a way to get even better deformations with even less effort. Cue the lattice deformer. This local mode thing just makes it look a little bit nicer when it deforms. Anyways, once you've got the lattice, run the script on the lattice to generate the rig, and then you can bind the skin to the lattice. Make sure you have the skinning method set to distance and 1 maximum influence. And that's because the skin joints are created at the intersection points of the lattice. And you can see that here. Now, if we bind the skin, each lattice point has exactly 1 skin joint affecting it, and consequently the deformation is nice and smooth and fluid. Look at that. And of course you can always use the smooth preview to make it look even smoother. I've got something very special I want to show you now. Take a look at what happens when I run the script with the node editor open. So we start out with just 3 nodes, and this one that doesn't really do anything. Let's select the cube and then run the script. Select the cube, and run the script. And ta-da, nothing has changed. Wait, what? What a fine bowl of pasta we have here. Delicious. This is actually where I got the idea for the name of my channel. You might think that I got it from the cycles and Eevee nodes that I like to make. But nope, I got it from this rig right here, because oh my gosh. Oh my gosh. Oh no, no, no. And this is pretty much par for the course in a Maya rig. And of course, those nodes are mostly math nodes of different sorts. There's a lot of math that goes into making this. And while I'd love to go into each individual tree and explain what the math nodes do and why they're there and how they work, it's just far beyond the scope of this video. And frankly, that's why I wrote a Python script, so I only have to do it once. I'm not actually planning on making this script available to the general public, and no, I haven't betrayed you, and I haven't betrayed the open source software community. No, but the reason is because it uses Maya and the Mel language, which interfaces with Maya, and the Python command API, which uses Mel to call Maya, and it's several layers of proprietary software. It just doesn't make sense to make it open source. Feel free to try to copy it, though, if you want to just freeze frame the video and try to type in the words one by one. You might find some very funny comments in there if you do that, too. But really, there's nothing to worry about. I'm going to port this over to Blender at some point anyways, and when I do that, I'm going to make the Blender script 100% free and open source and available to anyone who wants it on my GitLab. I might even make a video tutorial explaining how the rig works. Who knows? And honestly, it'll probably be a much cleaner script and a much nicer rig. Blender's got a whole bunch of features that you get for free just with the parameters of the constraints, whereas in Maya you have to make them from scratch with math nodes. Terribly tedious. Oh, shh! The trolls haven't found my channel yet? Don't let them know that I made a favorable comparison between Blender and Maya. In the meantime, consider this a little bit of a teaser. Anyways, if you thought this video was entertaining, or interesting, or informative, or if you just enjoyed listening to me brag for the last 15 minutes, go ahead and like the video. Maybe even subscribe if you like getting notifications every 3 or 4 months. Well, actually, I'm confident that I'll find a nice, steady, full-time job soon, and then I'll be able to pump out videos a lot more frequently, because I'll have a much more regular schedule. Until then, I hope you'll stay tuned. Thank you.